Thank you. Well, let me check this as well. Okay, perfect. Well, first of all, thank you for having me here. Thanks to the organizers, because my talk will be a little bit different from the general scheme of the conference. But thanks to the previous speaker, now we have a segue into this. I changed it a little bit, so if you read the abstract, which I don't think you did, I won't talk much about nanocomputing or classical computing, but I will go through some of the more social science tools that you can employ when thinking about this line of work. We are primarily in collaboration with TU Delft. So I'm Zeki, I'm at KIT in Karlsruhe, Germany, the Institute for Technology Assessment and Systems Analysis, and this is a work in collaboration with TU Delft, İlke Ercan, at the Microelectronics Department. Here's an outline of the talk. I will do a very brief introduction, because I know that I'm one of the last speakers speaking, standing between your lunch and your stomach, so I will do a brief introduction. I will talk about responsible quantum technologies. I will talk about the concepts of path dependency and lock-in, ethics as soft regulation and value-sensitive design, what about QEE, and energy futures, and some advertisements. And if you are interested in any of these, just feel free to reach out to me via email or LinkedIn. But first, a very brief disclaimer. Our institute is called Institute for Technology Assessment in English, but Institut für Folgenabschätzung in German, which translates to Technology Consequences Assessment rather than Technology Assessment. So we are mostly interested in the intended and unintended consequences and acceptability of future technological developments. We work very closely with the German Office of Technology Assessment at the German Bundestag and the Panel for the Future of Science and Technology at the European Parliament. Our project is called QTech at ETAS, which stands for Quantum Technology Innovations for Society, which is intentionally vague because we wanted to be able to do whatever we want. And the three main topics we focus are landscaping of the QT ecosystems, education and outreach research in QT, and something we call concept exploration and operationalization for ethical, legal, and societal aspects research on QT. And today I will primarily talk about that part. But as an institute, why we are interested in quantum technologies? Well, first thing is, everybody is. Globally there is this funding frenzy from the public organizations, primarily on being the first or at least not falling behind. And that's why, as a public institute working on emerging technologies, we are rather interested in the technology. And the second is, in Europe, as most of you might know, there is this thing called Quantum Flagship, and the motto is that the future is quantum, and technology assessment is very interested in the future, especially in projections and future studies, so quantum is something ripe for research in our field. And again, if you ever wrote a grant in Europe, you know this term, RRI, which is Responsible Research and Innovation. There are some strict steps like gender, open access, governance, all that stuff. But when I say responsibility, I refer to something a little bit more general. In terms of technology development process, we usually classify two camps. One camp is more, you can say, technology enthusiasts. Let's move fast and break things. If I remember it correctly, it was Facebook's motto at some point. And there's other camp, which in this slide, you can see there's environmentalists, but you can extend it to any kind of group of people who are kind of skeptical or worried about the risks of a technology. Well, responsible technology development primarily calls for some place in between. We need to be mindful of the risks, but we should also be aware of the potentials and benefits that a certain technology can bring. So it's considered as a ridge walk between these things. And something else in the field that I think might be beneficial for this community is something called the Coleridge dilemma, which basically stands for, at an early stage of a technology development, you, and this you can be like policymakers, researchers, companies, whoever you might be, have a more wider possibility of control over the trajectory of the technology, but you will have very limited evidence of impact. You might have some ideas of impact, you might have some visions of impact, but you will have very limited evidence. And one example I like to use, and if you were at yesterday's talk at CQT, sorry for this is repeating, let's say that in AI, there are a lot of people who are saying that, oh, AI will kill us, but they have no evidence. And let's say in 40 years, they come with very strong evidence when we have AI nurses, AI doctors, AI drivers. It will be really hard to change the trajectory of the technology. So it really helps to start investigating the potential impact of a technology very early on. To do that, there are some conceptual tools that you can use. One is called path dependence. I think coming from a technical field, we all know this, but there are some really funny historical examples. For example, the keyboards we use, even on our smartphones, which don't have any buttons actually, they are just touch, but still we use this QEI2023 framework or layout generally. And this is entirely because of the historical reasons. There is no added beneficial utility in using that over any other keyboard layouts, but we still use it. And the other example I really like to show is the size of a train is determined by the size of a horse-drawn carriage, which is determined by the size of a Roman road, which is determined by the size of a horse's ass. Well, two, technically. And you might say that, oh, this is interesting, but what is it to do with us? Well, there's a really cool video on how the size of a Roman horse's butt determined the size of the space shuttle. Yeah, so these kind of path dependencies have a much wider impact than we first might, think about. And, well, moving on to the next concept, which is lock-in, these path dependencies kind of emerge, not in the very early stages, because in the first stages you have a wide range of options. But then in time, you need to start eliminating those options because you need to just continue on a path. And as you continue on a path, the range of available options become less, and now you have a path. And in the marketplace, basically this shows as adoption, because initially there might be a wide range of options that you can choose from, but as a technology matures, then the number of potential options you have reduce because the market size is not infinite, and then you have to just stick with certain options other than the other ones. So these all things that I talked about, path dependency, lock-in, they are from the 80s. So they are not really related to very new and chic like AI kind of things. For example, this image or this graph is from a paper written in 80s on comparing Betamax versus VHS. And I don't think most of the audience even knows the meaning of those words, and I'm only very old enough to remember what they were. So what to do with quantum then? There is a growing literature and kind of a call from both the researchers but also policymakers, the parliaments on what to do with quantum technology. If you go to the academic literature, you can find papers like this, on ethics, responsibility, governance. And it's not just the academics who are interested in these things. For example, I'm sure most of you have seen this, the World Economic Forum's governance principles. So these usually take a very normative approach. They list certain values and certain principles that, we should be careful about. But there's another way to approach this, and it is called value-sensitive design or ethics by design. And it kind of takes the other way around. You go through the stakeholders and try to identify, okay, what are the values you think that should be embedded into the processes of the technology, products of the technology, and basically we should be mindful about. And primarily the value-sensitive design or ethics by design approach kind of stands upon three main investigation areas, and there is no, they are not sequential. You can do all of them simultaneously, and you should do all of them simultaneously in a sense. But primarily it's on conceptual investigations, technical investigations, and empirical investigations. So on a conceptual level, you should have certain values in mind, like sustainability, inclusion, diversity, safety, security, all that. So in that, the normative approaches help. In empirical investigations, you need to evaluate the stakeholder values through actually going into the field and asking them. And you need also to do some technical investigations, because just because you want certain values doesn't mean that they automatically translate into the technically possible realm. One example of this from autonomous vehicles. So if you run such an exercise for autonomous vehicles, as people did, you kind of find out that safety is the most important value in the field, reliability is the second, comfort is the third, and the bigger picture stuff comes later, like sustainability. So what this has anything to do with quantum technology? So one thing that I think we're all aware is the classical computing era is kind of stagnating, not in the sense that the number of transistors, but the frequencies, the power consumption, the speed of the gate switching. So primarily, everybody is kind of aware that we are reaching to a certain phase shift into the computing systems. And even beyond that, if you just look at the numbers, it has been really costly in terms of energy and carbon cost to continue this route. And for that, IEEE had formed this task force on rebooting computing. And primarily they are focusing on security, energy efficiency, and applications and human-computer interface. So there is room to discuss these topics, and I already know that now we have an IEEE working group, which is great. So this community should also be more active in the wider discussions in rebooting computing. So what would a value list or value priority look like for a quantum computer? We don't know, but one question we might ask is it the same for different modalities? Does it change if a different modality was to be the dominant one? And even further, there is a concept that we can use from legal analysis, which is called the hierarchy of values. And primarily it says that just because you have a list of values doesn't mean that the hierarchy between them is shared between all the stakeholders. So different people in the field might prioritize different values, which makes sense. So where to put QEE in all this? I think at least until now, QEE has been doing some great work in the technical investigations of what is possible, maybe what is not possible, what is probable in the technical domain. And whether the community wants to extend beyond that, it is of course up to the community and us. But just note that the things that we do in the technical domain or you do in the technical domain has a corresponding part in the wider discussion. So, the science and politics, they are related, so it's not like they are something apart. So, what about the energy futures? Well, QE is an example of, I think, a call for responsible technology development from within a research community, because this is primarily a research community here. And, it is acknowledging that there are benefits and there are risks. If I'm feeling it correctly, it is willing to walk the rich walk. And I will show that, okay, I will talk a little bit later on this. And path dependency on lock-in are, I think, obvious concepts that would be beneficial for this community and the discussions here. Because if there are options, such as more than one modality that can be scaled up, or other options within certain modalities, there is managerial discretion, which means you can choose between them. And of course, the Colin-Rich dilemma calls for an as early exploration of impacts as possible. So, in conclusion, well, first thing I think we should be aware of is technology and innovation are not science, and although we might be scientists, we need to be aware that the consequences are different. The second is we need to start early on thinking about the potential futures and try to map them. The third is inclusion of people, ideas, perspectives is essential to grow responsibly. And of course, you know, with great power comes great responsibility, so let's be responsible. Some advertisements. We have a call for papers. If you are interested in anything social about quantum technologies, just let me know. And we have been organizing this event series for the last 3 years. There will be the 4th one next year, April. If you're interested, just let me know. And QEI has been represented here, I think, twice. And we're also looking for a 3rd time. Thank you for your attention.
Questions? Okay, maybe let me ask a question. Because so curious to hear your thoughts on what you think might be the potential harm, because you had the slide about potential harm and potential benefits, and we talked a lot about, of course, computational advantages that quantum technologies bring. What do you think might be some of the potential harm that we can also bring?
Of quantum computers or quantum technologies in general?
In general, yeah.
I mean, well, one thing, one potential harm of quantum computers is that if it will make certain parts of the classical internet infrastructure vulnerable, which means even though there might be no attacks, there will be vulnerabilities and there will be consequences of those vulnerabilities and costs associated to those vulnerabilities. The second one might be on resource consumption. You know, we assume that they will be, or we work on so that they might be more energy efficient, but you know, rebound effect is one of them. Helium consumption, maybe another, because it's a non-renewable resource. I mean, of course, there are other stuff that cost helium, which are much less useful than quantum computers, like balloons and stuff. But still, you know, in the long run, it might be. And again, one thing is, you know, the dual use aspect, not just in the sense that it can have military uses, but also if something can be used for accelerating drug discovery, it might also be used for accelerating bioweapon research. So there needs to be some awareness of that at least. You know, it's not like, oh, this is such a huge risk, but at least be aware that this is possible.
What are some ways that we can incorporate, what are some practices we can incorporate into our daily lives as, you know, regular working days as quantum computing scientists to maintain a more, like a broader ethical perspective on the work we do? Because obviously it's very easy to lose sight of that, of that kind of any kind of broader perspective when you're hyper-focusing on a very specific analytical task. Are there any particular practices that you recommend, you know, or journals to read to keep your mind open on that kind of thing?
Well, thank you. That's a very, very good question. And I see groups popping up everywhere focused on this. For example, at CQT, you can reach out to Clara and Fernando for this. There are also initiatives like the Quantum Ethics Project, you know, Responsible Quantum Network, you know, they're focused on this. But on a personal level, there's something we call moral sensitivity. So it's not moral judgment. You don't have to judge whether something is ethical or something is not, but be aware of there are these aspects that go beyond the technical work. So you can educate yourself with even YouTube videos on it, because there are some very accessible stuff out there. And also, you can just join events like the Responsible Quantum Technologies Workshop that we also have recordings online, so you can just watch them. So, yeah.
I have a question about what you said at the end about these kind of the fact that there are managerial decisions that come with the fact that there are many options, and that essentially there are choices to be made, and that you have to somehow watch out for at some point you have this lock-in. And this is nice when you think about it from the point of view as we are one harmonious community and we kind of explore around and we make decisions together, but in reality we are not really a democracy, right? I mean, you could say it from a community point of view, socially. In reality, in quantum information, there are a few very, very influential names, and when they say something, this kind of becomes the community opinion. And I mean, we can discuss about that, but this is more or less a fact, I would say. Then, at the same time, you have people in our community who represent us on government levels. We have these people in France. This is not a democracy. Like, these are people that I mean, I've never voted for any of these people to represent me. They're chosen by the government as kind of randomly. This is someone that we like or that we by chance know, so this will become the representative of this community. So how do we deal with this fact that somehow we as a community have to make ethical choices, and at the same time we don't really have any kind of form of real democratic representation?
Well, thanks. That's a very good and loaded question. So one thing that we might be careful about is when we are thinking about ethical issues, there are, macro ethics and micro ethics. So there are these macro issues that, like climate change, like the authoritarianism, or, nobody elected, all that stuff. But also there is microethical issues, like how you conduct your research, how you communicate your research, how you talk with others, how you talk with the public, how you talk with your friends on these topics, and the things that you care about and you signal that you care about. Because, I mean, here we have CEOs of companies, we had someone from IBM, and just be aware that even though you think you might be, powerless or have very little choice or option or influence over those options, there are a lot of researchers, and just think about in a neural network, certain nodes might have a much higher weight, but still all the other nodes contribute to these things. And if you think of a single pixel attack, even a single pixel has a huge effect on the outcome.
All right. I think probably I'll rob a very quick one.
Just use my power as one of the organizers. So I'm going to ask a question, but we don't have time to answer it, but I just want to maybe launch the discussion. I guess what I really liked was your slide with the three pictures and saying that the QEI, I agree, we're in the technical investigation part, and probably that's where our center of mass will always be, because we're scientists and we want to do good quality science as our priority. But then the question, I guess, is how the interfaces work with the other parts of the triangle. And maybe to be inspired by, for example, artificial intelligence, which I guess is a bit further down this road, about how those interfaces did or did not work in artificial intelligence. And so I would love to hear maybe another 20-minute talk about how exactly this worked in artificial intelligence at some point.
Or didn't, right? Just the
didn't.
drama
Yeah,
of the couple
I don't
days.
even know.
Yeah, I think it's good. It's a good question, and of course, I mean, if you're interested in this stuff, just find me during lunch or dinner, and we can discuss. And one thing I might say regarding both answering the democracy question and this, we don't have, and maybe we shouldn't have these systems of elections and stuff, but people who are not self-electing, but standing up to represent certain communities and certain options, it really makes a difference. And if the people who are not those people are against those people representing themselves, they can also stand up. Because it's, as you said, it's not a democracy, which means after the votes are counted, there's a winner and there's a loser. No, it's a continuous process. So if you want your views to be represented, and just stand up.
All right, thank you very much.
Thank you.
And we have the final speaker.